and present some fairly old research from last year, but I never had the time to publish. But I think it's still kind of an interesting topic because nothing gets old in Open Samba. So most of the findings they still apply. So and I can kind of jump back between the slides to kind of show you how does it look today. So the title of this talk is Data Mining Open Samba. And I don't know how many people are familiar with the kind of Samba protocol, but essentially it's the most common protocol for sharing files over a network. And I can there's a few slides after this where I can kind of describe what it is exactly. But just about myself, currently I'm working as a senior data scientist for Fortinet. Please don't ask me anything about the latest leak because it's not fun. The CV 2018. People ask me that, and I kind of get bored about that. I previously worked for Microsoft and Context Information Security, and essentially I've been a senior data scientist for those companies. And my background is software security. Well, I'm a software engineer, software and automation engineer. That was my major. And I have a PhD in artificial intelligence and robotics. I've been hacking the entire for most of my life since I was a little child. Mostly I specialize on reversing software, most of that. And then obviously I have a passion for data science and cybersecurity. So that's what I've been doing recently. So I want kind of to learn more about the kind of Samba protocol and how does it look like on the public internet, and see how prevalent it is. This talk is not about monitoring or discovering vulnerabilities like the Eternal Blue from last year. And obviously this is my own research. It's not, I haven't done that with my current employer, Fortinet, but I also mentor a couple of startups, and one of them is Priyam Cyber AI, and so that's my email. If you want to contact me about this kind of specific research, you can reach me there. Oh, next slide. Yeah. So I'm going to talk a little bit about this, the Samba protocol, the kind of tools and services that I've used, how do you scan the internet, and how many Samba boxes are exposed on the internet, and what kind of attack scenarios you can apply from that. So NAS stands for network attached storage. It's kind of becoming an increasingly popular device, for consumers. And it's obviously that's a kind of market share in US in terms of USD millions. And I mean, it's not like an exponential growth, but people both for home use and business still buying these kind of devices. I have two in my house, and I have one for kind of personal family stuff like pictures and videos where I back up all my material, and then I have a work one where I basically store my code and backup. So I'm sure a lot of people are using like the maybe different vendors, but it's the same kind of concept. You can build one as well if you want to. So a little bit of the about this kind of Samba protocol, and so the kind of first version was, a lot of people think it was Microsoft, but actually was designed at IBM in 83, and originally was working on top of NetBIOS and NetBerry. I don't know how many people have used that. I still remember, building LANs on NetBIOS back in the days. Nice memories. And essentially after that, they kind of, the first implementation was, you can run it over the UDP or TCP protocol. In Windows 2000, they introduced Samba 1.0 that worked on the TCP 445. And then there was Vista 2006. It was, Samba 2.0. 2.1 was Windows 7 and basically Server 2008. And then, up until recently where, we have, 3.1.1, Windows 7 and Windows Server. Now, SMB stands for server messaging bus, and there's a lot of confusion about SMB, Samba, and CIFS, Common Internet File System. Essentially, the Samba was the name of the software that was originally commercialized. CIFS, Common Internet File System, was essentially a dialect of SMB, server message block exchange or server message bus. And it's kind of confusing, but SMB it's essentially is a protocol, and it runs also on Linux. Linux boxes that emulates or implements that protocol. But obviously, if you get Windows, it's already installed as one of the default protocols for sharing files. So for this particular talk, I'm a data scientist. My main tools are Python and Jupyter notebooks for as the kind of main language. I like to use Google Colab and Kaggle as a free GPU Jupyter environment. And you can do some pretty cool stuff on those sandboxes, because you can actually install tools like Nmap and stuff like that. So you can run Samba clients, Nessus, Mascan if you want to. Obviously some of those activities will not be fairly legal if you do like Mascan from a Google account. And then as scanning services, I've used Showdown, Chances, and FOFA. And then a couple of other libraries for like doing machine learning, NLTK, Scikit, and TensorFlow. So if you go on Showdown, and I can actually switch to my account now, and you basically look for the for the Samba port 445. This was last year, by the way. I can switch to now. There's a lot of open shares essentially exposed to the internet. So that was like last year, 280K IP addresses at essentially an SMB open share, and only 54. Well, yes, there were an additional 54,000 which were protected, right? So they had authentication enabled. Now it's very important when you use Showdown to remind you that you are scanning an external IP where inside that network there could be like different devices. So the actual operating system that Showdown detects, it can be an aggregation of different devices, right? So it might say this is Windows 10 or Windows 6.1 in this case, but actually the actual NAS box, it's a Linux device, right? So but when you do the fingerprinting with Showdown, it will just look for example, an internet, a Windows server, and then it will just mark that as a Windows OS. So you shouldn't really rely too much on the on that specific system. I can actually show you how this goes. No, we can do that later if we have more time, but you can run the same queries after this, and you can find like similar numbers if you do it today. It's also kind of very important to remind yourself that when you're using these kind of scanning devices, scanning services, there are different footprints on the internet. So obviously, Showdown has mostly US and Europe scanners, but it's always good, especially in data science, to kind of correlate different engines. So I went to Census and they did the same query, and that was last year. There were according to Census in US alone, there were like 43 million open Samba devices, which it turns out to be a bug. when I called I basically reached out on their support and say, yeah, there was a problem with the way that they were represented. If you do it today, there are far less. Like if you do the same query today, there are like 90K or something like that. But I can go on the system after that. So that kind of looked odd, and it was indeed a bug. So always cross check. And the other things that stood out when I was doing like Showdown results, you can see later that there weren't many Chinese devices. And the reason, well, my explanation for that is that probably the Chinese Great Wall is probably blocking most of the Showdown or Census scanners that are operating outside China. So if you run it from profile, you can see that there are indeed more IP addresses, which still looks pretty small, to be honest. Like for a country as big as China, there were like between 2018 and 2019, there were like only 3,000 devices. So yeah, it was going to be surprising, and this is kind of part of my job when you do these. It's like, oh wow, like there are very few devices that they're opening Samba ports, and I don't know if there are ways for the Chinese government to block this kind of scanning activity. Maybe I'm not very familiar enough with the sort of network in China, but there was certainly more than Showdown was showing when I was doing those searches. But there was this drop, which is kind of very strange. But you can see also like what kind of organization were basically exposing their Samba shares outside, which is interesting. So the way I did this research, that was from last year, 2019. I took a slice from the Showdown API, and I basically scanned about 200,000 DOS, which had authentication disabled. And I just kind of wanted to see legally what kind of information I could get out of those Samba shares. And if you look in terms of distributional scans, I was kind of also interesting to see how Showdown scan volumes change over the week. And you can see that for some reason, on Thursday there's kind of a less activity, and Sunday for some reason there's more variation of that. But essentially they do scan sort of regularly. They spread the scan over the week almost uniformly, except for Thursday, which is interesting. So the first thing I did was like, oh well, okay, let's look at the distribution of Samba versions over this population of 200,000 devices. Well, unsurprisingly, I would say that version 3 was the kind of most popular one, so it made 87% of the entire pie. And then there were like versions like Samba 4, which was fairly new, I think, in 2019 when I was doing that. So they kind of explains that, right? These kind of new versions, not a lot of vendors were selling NAS devices using those ones, but the kind of most popular ones were from the kind of stable older versions like 3.0.37, 3.3.4. So yeah, so this looks like a classical bimodal distribution where essentially everything is concentrated and then everything else is almost zero. Then of course, like very simple thing I did was let's correlate the Samba version with the vulnerabilities from the database, and the CV score, and you look at the top 10 vulnerabilities, so out of 100. And you can see that essentially this CV 2007 were 10%, 2004, 2015, etc. So if you're familiar with the CV numbering system, that means that roughly the first number is the year where that vulnerability was discovered. So you can see that actually you can find some very old boxes that are still vulnerable out there, right? So you can see from 2007, 2004. 15, okay, 17 was for a couple of years back, and like 2009, 2007. So if you're a malicious attacker, it's pretty easy, like to exploit the box, because those are critical 10 level 10 vulnerability. So you can basically pretty much all those boxes. Now they could be honeypots, of course, like a percentage of those ones could be honeypots. That's true. We don't know how many of them that were like fake, just waiting to be exploited. But it's probably a small percentage of that. So you will still be successful if you want to basically build your own botnet or something like that. I also look at kind of the distribution of countries using SMD, and that was kind of as well was kind of a little bit of a surprise. I was expecting for some reason, I don't know, US and maybe like some, I don't know, like Central Europe country like UK to be at the first place. But surprisingly, and I can explain this, that Russia was one of kind of the countries with, like the most of the devices that were exporting Samba. And 76%, it's pretty big, followed by AE, so the Emirates, Finland, Canada, US, Italy, Taiwan, Portugal, PA. I can't remember what PA, and Great Britain. So and I mean, if you look at the kind of population, you could do some normalization there. Say, well, Russia, the population is 144 million, but US is 327 million, and it's kind of more developed country. People would say why US is not there. So I don't know if there is an explanation there and why Emirates are there, but it's kind of interesting why Russia. So I don't know, there could be a massive honeypot operation going on there, or it could be that people are less careful about deploying NAS devices on their network. I don't know, but I think it's kind of interesting that most of them are in Russia, or at least connected to a Russian IP, because obviously geolocation is not 100% accurate, so we don't really know if they are really based in Russia, but that's what the geolocation tells us. And you can do the same distribution for files. So we're actually because you can have boxes that maybe share like a couple of folders or printers, but they are empty, right? There's not really any content on that. So I basically ranked them by the total amount of files that they were containing. And okay, Russia was still at the top, so they were actually full of content, those Samba shares. But then the kind of distribution changed. So there was France, Italy, US, Taiwan, Great Britain, China, Hong Kong, Spain, and Poland, right? So you can see like there was a big shift in the distribution there. In terms of ISP distribution, I wanted to see if those boxes were essentially on a private network or on a, let's say, on a cloud infrastructure, because if the IP belongs to, let's say, AWS or like I don't know what do they have in Russia or China. Obviously, you can be pretty sure those, they could be honeypots, they could be corporate boxes, but it wasn't. So like, the Russian connection seemed to be Worcester Telecom is basically a national provider in Russia for for broadband. In the Emirates, it was the Emirates Communication Corporation. There were a bunch of other things that you have to Google. There was one from Panama and the other stuff, but HiNet, that's from Taiwan, and Italy. It's not on this graph, but you will see it later. So they look pretty much legitimate NAS boxes, right? That kind of gives me more confidence about not being honeypots essentially, but you might still have people doing some interesting stuff with IPs and maybe trying to build a very realistic honeypot. Okay, so that's the kind of stuff I was saying, like the one that does contain files. It's kind of pretty much same distribution, but you can see like Orange was for France, HiNet for Taiwan, Telecom Italia, which I'm from Italy, so is the kind of one of the most popular service provider. Swisscom, Fastweb, and Vodafone, all the kind of major, basically, service providers for them. So that was kind of very interesting to see. And then I kind of look at the share type distribution, right? Like, do we just see other kind of things? And yeah, we got printers. Like you have disk, basically almost all of them at a disk and an IPC share. But there were like 290 that even had printers connected and exposed to the internet, which it's kind of, obviously it's kind of a fun thing to do, maybe to print random stuff into somebody else printer. It could be scary. I was doing that as well when I was younger, to have fun with some of my friends. But nowadays you can actually exploit them, right? So you can actually exploit the printer if you want to, and then you basically can get a foothold into a private network. And I've seen cases where attackers have been using printers to as a pivot point into a corporate network. So that's kind of interesting. Okay, so the other interesting stuff was the IPC share. So a lot of people probably remember that because it was used by Configure. There was an exploit where essentially you can use that mechanism to own a box I kind of looked into that because I was thinking, well, if those shares are probably personal NAS devices and they're Linux, why there is an IPC share that essentially relates to a Windows protocol, right? But actually, if I had a look at my own Linux Samba box, and even like the Linux distributions that implement Samba, they do need to actually emulate the actual IPC share, inter-process communication share, and the admin share. So like this doesn't really tell you that those boxes are Windows boxes. It's just the way that the Samba protocol needs to work. You do need to have a way to advertise the services to be discoverable from the network. I think there is a way to disable that. I'm not 100% sure, but this doesn't tell you they are vulnerable to configure. If they essentially most of them are probably Linux boxes, right? But it was kind of interesting. You can if you're not familiar, you can read about config and how they managed to exploit that for the admin share and the IPC share. But yeah, it was kind of interesting to see that. In terms of distribution of the kind of admin share, it was kind of similar to the other ones, but there were less. But yeah, it was mostly US was in the first place, and then there was Taiwan, Hong Kong, the other ones. And I don't know why. It's probably because as I said, particular versions were prevalent into that country, but they were small, right? So there were very few 780 hosts were basically sharing, exposing the admin share. So and obviously, legally I couldn't do any more digging. I'm just presenting those facts, and obviously when you start to poke with those boxes, then it becomes a sensitive topic. So but they were kind of equally spread across different countries, which is interesting. And then I look at those printers, like where are those printers, right? So Taiwan had the kind of largest amount of printers, and then there was France, Italy, US, Russia again, Singapore, Spain, and other countries. So there wasn't really a specific focus, but there were very few of them, right? So they were basically people that somehow they left their printers connected. And I think the reason for doing that is that nowadays you can essentially, and I have tried that with my device as well, you can actually connect a printer to your NAS for convenience, because then you can essentially print documents from from that software. But unfortunately, it depends on the vendor. They basically get automatically configured to expose that as a device. And I think what happened in those cases is that people have left the box connected to the internet, and then essentially the printer that was attached to that is also visible from the outside, which is not very nice. But yeah, that was kind of interesting to see. I then looked at the kind of names that were exposed from the printer share, and with very simple NLP processes, almost like a regex. You can essentially extract the kind of most relevant terms, and there was the kind of the most 10 common names that were tokenized and were extracted were like LP, which is kind of a default name, so that's really too much. Printer obviously is a printer. PLF, I'm not sure what is that, but then you can kind of look at more specific names, and you can see like, okay, LaserJet. Well, you just know that the printer is a LaserJet, but then you can get, in some cases, even the actual name like HP-Jet 6122, which will be enough from an attacker's perspective to basically narrow down the attack, the attack search, right? Because you can basically find a vulnerability for the specific version, and you can try stuff. This is I think this is kind of popular nowadays. Like you have a word cloud where you can actually each word is proportional, each word dimension is proportional to the actual prevalence of the finding. And yeah, you can see like the generic ones. There were very specific ones like Samsung C4 3X. you can take a look at these later. It was kind of interesting, LaserJet P17. So pretty good finding. I wasn't expecting to see that, right? Like basically leaking information about the printer from the share name, which is very easy to fetch. So I look at the kind of IPC share name, because I was thinking, well, okay, let's look at that as well, right? Maybe there's some other information leaked there. And yes, indeed, you can find the Gpawn thing. So Gpawn is a manufacturer of boxes. So at least you know that it's a specific device. You have kind of generic things like DSL gateway, can be anything, NAS server can be anything, but then you can, look at these things like RTCN 8190, which is very specific. Some of them were empty, thanks God. WDMI Cloud is a software package from a hard drive manufacturer, so you can guess what that is. And then like 2-bay NAS, kind of too generic, you can really use that much, but yeah, it was pretty good. And this is the kind of word map again, so you can you can start to see some pretty specifically things like the Samba Server 3.6, the actual version is there, Seagate Central Share Storage, MyCloud Pro, sometimes even the Linux version, right? Samba 4.5.16 from Debian, Samba Server 4.76 Ubuntu. So you can, like with very basic information, you can guess what kind of OS is behind that, right? Zixel devices and whatnot. So yeah, I was surprised by that. And then I kind of thought, well, let's look at the kind of file name distribution, like so the extension, right? I just want to see what's the kind of most prevalent distribution of files. And JPG was the kind of most common ones, and I guess that like the theory again is that those are kind of devices for family backups and whatnot, so you can expect that. I found like .so, which is a compiled Linux library. It's like, oh, okay, maybe there are some backups in there. And at the third place, I found this numpo. I think I don't know how to pronounce that, numpo-u, something like that. And when I saw that, I went to search online, and actually just a few days after, or was it before I was doing research, there was some researcher published that yes, there was indeed probably the first ransomware attack where the attacker was essentially scanning NAS devices and was basically cryptolocking the actual content of those shares. So like so I just pure chance, I just did find the same attack that researcher was talking to. I think it was a few days before or a few weeks, I don't remember, but it was kind of interesting. And there was like there were other stuff like books, and then a few sort of ranks after that. There was the CryptoLocker, so .cryptid. So maybe it was a backup that was corrupted by ransomware. I'm not really sure. And then text files, PNG, the usual stuff, drawings and whatnot. So the kind of total amount of file on that week was 440,000 files, 54,000 shares, and for a total amount of 93 terabytes. So that's I mean, it's obviously, if you look at the entire internet, it's not a lot, but you can work on those on those terabytes. And I think I have some few interesting conclusions at the end that previous speaker can also find interesting. So I kind of looked at the victims of that ransomware attack I mentioned. So the the num4u and the kind of CryptoLocker, and yeah, unsurprisingly, they were based on the countries where, except for Russia, which is kind of interesting, those countries were essentially the one that had the most files. Once again, except for Russia, and that's France, US, Italy, Taiwan, Great Britain, and if you just go down that list over there, and once again, this was kind of very interesting. Like, how the attacker consciously, like, somehow I don't know why did he exclude Russia, right? So 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 I don't want to kind of draw like a sort of a conspiracy theory there, but there could be the chance that maybe it was originating from a Russian actor, maybe that it was specifically not targeting Russian IPs. That's a kind of logical sort of follow up on that chart. But it could be a coincidence. I don't know. But you can see all the other countries except for Russia, which had the largest amount of shares and available, which is kind of interesting. But yeah, let's go forward. And then I kind of looked at just essentially at the kind of common document file formats. As I said, besides pictures, there were also like documents like PDF, text files, CSV, and whatnot. So that could contain fairly interesting information, I would say. And then you have like pictures files, JPEG, PNG, and that kind of stuff. So I was kind of expecting that. There are also a lot of compressed files, which probably kind of relates to the fact that they were backups, so like zip files, GZ, RAR, TAR, and the usual formats. There were also, binary files. There were a lot of them, and I think probably most of them, there were once again backups of programs and maybe installation files and that kind of stuff. So that was not very interesting. But the cool thing is that there were also like source code and all sorts of files. XML, okay, that's it's just probably not very important. PHP, okay, so there's it could be interesting. SQL files, JavaScript, Python, JSON, Java, C files, and whatnot. So those again could be backups, could be like a genuine intellectual property from from the person that was doing a backup, but also in terms of most interesting files, there were .pub, .pem, and .rsa, which are typically, well, except for .pub that can be both like a document format, but also the public key file. There were indeed 17 keys from .pem, which are essentially OpenSSH keys that you can use to access a system, and even like 2 RSA files. Now, they could have been encrypted. Obviously, legally, I couldn't go and check, or they could have been clear text without password. So that means an attacker could go there and take those keys and try to figure out where they were connecting to. So that was very interesting. I also kind of looked into, I didn't want to do like a very complex analysis, but essentially took the file names and only extracted those ones that were in English. Obviously, all the kind of Russian file shares, I kind of ignored all those ones. And I kind of looked at the kind of in terms of shares, folders, and files, how many had essentially an English language on that. So that was the cross section of that. And I did once again the usual word cloud, and that was okay. There was the obvious backup, but then you can find things like emails, iPhone, phones, firmware attacks, loans, selfies. Then you start to look at other things, less probably more personal things like sex, naked, date. There were RDP folders, probably settings to to access an RDP server, and unfortunately erotic and that kind of stuff. So there was there was also a folder named patent over there. So Gmail, and yeah, that was kind of interesting. Like I mean, you can if you are a criminal, you could find pretty much information that you can use to extort, to basically apply extortion to the specific victim, because you can find even his picture from a holiday or wedding, and I don't know what was in those other shares, but you might find some other compromising picture, let's say, and you can easily basically blackmail persons by doing that. And yeah, that was very I guess it was not that surprising that people keep those kind of obviously content on those shares, but even like things like finance, Gmail backups and that kind of stuff was kind of a little bit of a surprise. So I kind of through those slides. We are 40 minutes, okay, so I'm on time. Obviously, you can. So if I'm an attacker and I want to build my botnet, for example, I can do the same analysis I did and just essentially brute force or even basically select the vulnerabilities I want to do, like Eternal Blue, which is exactly what happened with WannaCry and Pedia, right? So that already happened. So it's kind of old news. If you have, if you want to apply a more recent low sort of easy game, you can basically launch a ransomware attack. So you can crypt files like Megalocker or apply extortion. So obviously there are two constraints when you do that. Bandwidth is one, because if I'm accessing the specific share remotely, I might not be fast enough to lock all those kind of files. So maybe the person will realize that this is happening, will disconnect the device, hopefully. Although I wouldn't be sure about that. And if you want to be more, let's say, if you want to essentially have a longer, like more, let's say, complex attack where you basically select those specific victims and say, oh, let's see where's pictures and specific things, and just work on one victim at a time. So you can do that. Obviously, there's a cost for a criminal. There's a cost benefit analysis that they can do there. And I'm actually surprised not to see many like articles or research being done on this one. And I don't know if it's sort of underrepresented and people journalists don't really, I guess it's really hard for people to, if my ad gets and I did some research like on forums where people were saying, oh, like I can't, like my pictures were, my pictures, I can't open them anymore. Like, and there are people trying to sort of figure out how did that happen, and basically what they realize most of the time is like, oh, you left your NAS open to the internet, right? So I can see that there are actual people complaining about in forums, like generic forums, but it's not that something that like say like a news magazine will pick up and say we found this, because it's kind of harder, right? You have to kind of try to get information from forums and see if this is happening. So that's one problem. As I mentioned before, and this kind of I think matched beautifully with the previous talk, you can build a digital persona. So you can basically construct an entire profile for the victim. You can take his real picture, you can take his address, if there are backups of his passport, you can take that. So you can actually see your entire identity by looking into these NAS, and so yeah, it can be used to that, or for externals, as I mentioned before. You can be more creative, and something I didn't mention is that all of those shares that contain files did have write permission, right? So what you could do as an attacker is to go there and start to inject back those macro into documents, HTML, anything that you can get, all like binaries, right? And you can even be very scientific about that, because you can actually say, well, let me look at the most recent files, which are the one that probably most likely the person is going to reopen, right? So you can go there and and do all sorts of injections, and you can essentially wait for the victim to open one of those files, and then bam, you basically have a backdoor into that person, and you can start to build your botnet, like in the first case. You can also obviously steal intellectual property and PII, as I mentioned. And I've been told, obviously, I couldn't do this kind of analysis, but I've been told that, yes, they did find, in some cases, folders where specific user the server information on a file and RDP configuration file on the other one, and essentially it kind of say, and the same RDP server was on the same, was exposed as well. So the person, basically the attacker, would have gone into his share folder, copy those credentials from one file, use the other one to log into the actual desktop computer. So and as I mentioned before, there were files about patents and sort of stuff. So it's it's pretty doable. It's not sci-fi. And last but not least, we've heard a lot of criminals starting to leverage machine learning for evasion, deepfakes, and that kind of stuff. And you can do the same thing I did. I mean, obviously, I didn't download those content because it would be illegal. But if you go down to that way, you can build a fairly easy pipeline with open source software where you can go there and download stuff and classify that. Give me all the Samba shares that contain faces, right? So I can then just focus on those specific ones to make sure that maybe I want to look at real people, right? So if I want to do that kind of PII exfiltration, that kind of stuff, anything that looks like a passport, download text files and tell me which one contains passwords, that kind of stuff, right? So it's something that it's fairly easy, and you can find source code on the internet to do that. You don't really have to code it yourself. And some of the stuff I said before, you can go on these free platforms, like Kaggle or Google Colab, where you can actually run any tool you want, and you have a free GPU, so you can actually be fairly anonymous if you manage to register the account. Which nowadays is a little bit harder because they at least require phone verification, email verification, and a couple other things. But I've seen people bypassing that fairly with a little bit of determination. You can create an account on Kaggle and Google Colab, and then essentially you can have essentially a server where you can do all this kind of illegal stuff. So it's pretty easy. Mitigations, and I kind of thought about doing this kind of stuff, but obviously I didn't want to break the law. But like if what you could do is, and you have to be creative. How can you notify those people, right? Because you don't know them. So I was thinking maybe you can print a page to the printer to say, hey, we have found this your NAS device. Please, please make sure that it's not connected to the internet, and stuff like that. Or you can even drop a file in one of the most recent folders, like you can call it something like "Please read me now," and hopefully, if the person reads that file, we can realize what he has done and maybe remove those shares. The other things I'm trying to do now, which would be fully legal, is essentially deploy a honeypot to measure activity. And why I want to do that, because I can kind of monitor if there's any ransomware campaign targeting NAS Samba servers, or if there is like crawler behavior or exploit behavior, or just like recon behavior like Showdown. So so that's kind of it's essentially just building like a data source, a data point where I can actually sort of monitor if there's anything interesting going on. So just one, I know that most people are very security aware in these talks, but you can go to this code and on Colab, and essentially you can basically, I can show this now, 48 minutes, I think. You can essentially get your IP address of your router, and you can scan it with Nmap to make sure that that you haven't exposed anything on the outside. And I can stop. I think I can quit these slides and I can show you that, but I will do that at the end. So what's next? And this is really something that I will maybe come back next year to talk about. This is what I'm doing now, and I also like to thank everybody in the channel that is kind of asking me, because I don't want to use a specific Fortinet product to do that. I just want to do something that everybody can sort of other researchers can develop to deploy like a fairly realistic honeypot. And the idea is to not to deploy. So the problem with honeypot that you deploy on AWS, for example, like real attackers will not fall for that, because they can just check the IP and will not even try to do anything, right? So you will get the kind of most generic malware, and I'm not really interested into that. I really want to see if there are people trying to download content and or try to encrypt content from shares. So this is what I'm thinking. What I'm trying to do now is essentially to have my home router on the DMZ, and then connect like an inline sniffer, like Netgate, pfSense, or as mentioned, FortiGate. But that would be, like I want to do something with open source, and then a Raspberry Pi with a real Samba Share, with like release like files that they can drop in there, and essentially monitor that through a dashboard. So that's a kind of what I want to do now. And if you look at the kind of honeypot for SMB, there are only two. And if anybody knows about other ones, please let me know. But there's the Python Honey, which is 4 years old, and is not that high interactive. And there's the Dionai Samba emulator, which is okay, but also that project has been abandoned. There are a few maintainers. So if anybody knows anything about more interesting like honeypot software, they would be useful. So so thank you for that. And also, I'm also involved in other things. So I'm one of the, well, no, I wouldn't say co-founder, but co-author of the ETS Scoring System that was presented at Black Hat. I think is now 1 year ago or 2 years ago, I don't remember. And it's basically an evolution of the the CV scoring system. And you can go and check that. It's pretty good. It's basically an exploit prediction scoring system, which is basically based on machine learning. It's pretty cool. I encourage everybody to check that. And this year I also released this tool at Black Hat called Invoke NTVM. Which is basically just an interesting tool to fingerprint VM. And if you want to reach me out personally, that's my email.